Number 1, change 175 degrees to radian measure. So what's your strategy on doing these kinds of problems? What do you do?
Divide it by 1/8.
Okay. Yeah. And then add pi. Okay, so it's always degrees on bottom and pi on top. So you can simplify. And what's the common? 5? So what does this reduce to?
35 over 36.
Yep. Questions on that process? Pretty straightforward. And now we're going backwards from radians to degrees. So we're going to multiply by 180 over pi. Pi's cancel. That goes to 60. So 300 degrees. Did I do that right? Okay. Does that make sense? Okay. Negative 2160 in radians. Can cancel 1 0. So we have 216 over 18. Does that go evenly? Yes. Good so far? Mm-hmm. Everybody has 100 so far?
Yes. Yeah.
Good. Don't know. Okay. Suppose theta is an angle in the standard position whose terminal side is in quadrant 3. So I'm just going to stop there. Quadrant 3. I always draw back to the horizontal. There's theta. And secant theta is negative 17 over 8. So secant's the inverse of cosine. So that means that cosine would be negative 8 over 17.
And there's only one answer that has that.
Okay. So you could stop there, I guess. Cosine's negative 8 over 17.
D.
Here. If we have more than one answer with that, what do we fill in here?
The opposite side.
It's a special right triangle. But if you didn't know, you would take 17 squared minus 64. So 289 minus 64, the square root, be 225, 15. Okay, and then you could do all of the sine, the cosine, all of that. And this would be negative also because it's in the third quadrant. Questions on that? Okay. Find the exact value of negative 315 degrees. Well, negative 315 is going to be in the first quadrant, right? Because I'm going to go this way. And what is this angle going to be?
45.
Yeah. Okay, so I know that this is, right? It's square root of 2 over 2 for x and y. And I'm trying to find sine. So that's this. Because it hasn't been rationalized. But if I were to draw this triangle, right, it would be 1, 1, square root of 2 if I didn't do it in the unit circle. Sine is 1 over the square root of 2. Okay. Find the reference angle for 288. Well, 288 is in which quadrant? It's going to be here, right? That's the reference angle. The reference angle is always to the horizontal. So 270 is here. Another 18. I take 90 minus 18.
72.
Mm-hmm. Okay. If sine theta is negative 3/7, what's cosecant? Negative 7/3. Okay. If secant theta is negative 1.2, secant theta is negative 1.2. So what quadrant would secant be negative? There's 2. It's where cosine's negative, right?
It would be.
Either this quadrant or this quadrant. So let's just do it this one. And if it's negative 1.2, well, that's negative, give me a, how would I write that as a fraction?
1.2.
As a,
Negative 12 over
right? Or 6 over 5. So this would be negative 6, 5. This would be 6, right, for secant. And I'm trying to find sine theta minus pi over 2. Well, sine theta minus pi over 2, that's theta minus 90. This is theta, right? If I go 90 here, this is theta minus 2, or minus pi over 2. I'm theta subtracting pi over 2. So it's really, what do I want to say here? Theta minus pi over 2 is here. So I'm going to take 90 minus whatever my theta is. You know what I'm saying? It's the complement of that angle. So this angle is cosine. So cosine of theta is negative 5/6. Sine of theta minus pi over 2 is going to be in this quadrant, and it should be the same value as this one because it's the complement. You know what I'm saying? I'm not explaining it very well, so I'm going to explain it better. If I actually find the angle, inverse cosine of 5 divided by 6. The angle here is 33.6 degrees, right? If I make its complement over here, that's going to be 56.4 degrees. And I'm trying to find sine of 56.4. Okay? Which means this is 33.6 up here. So that means this is 5, this is 6. Is that right? No, adjacent.
Yeah, the 5 would have to be.
5 and 6. So sine of theta minus pi over 2 is the same as cosine theta. That's what I'm trying to get to. Did you follow that logic? So it should be 5/6, which is 0.83. So I just took theta minus pi over 2 goes the other way, so I'm going clockwise, which means this angle has to be this complement. So sine of theta minus pi over 2 is going to be cosine theta. And cosine theta is this, but since it's in the first quadrant now, it'll be positive. And if I had made my triangle down here, which is the other way, it could have been negative for secant, and moved it, that pi over 2, to the second quadrant. Do you see how sine's positive in the second quadrant too? So it wouldn't have mattered. I'm still going to get a positive number for sine, because it's going to end up in first or second quadrant when you move backwards pi over 2. Okay, I want to make sure, because I think I made that a lot more confusing than I needed to. But follow my logic?
Yeah.
Okay. Stop me when you don't, because sometimes I confuse myself. Okay, what basic trigonometric identity would you use to verify this? Yeah. You just set that equal to 1 over cosine secant, and you're done. Magic. Okay, find the exact values of the trigonometric functions for secant of 13 over 3 pi and cosecant of 7/3 pi.
Can't be B because that's cotangent. It's for the second one.
Okay. 13 over 3 is what? 180 over 3 is 60 times 13. I always like to do, that's that right? 180 over 3 times, so that's 780 degrees. Okay, so 780 degrees, if I minus
That's 60.
720, that's 60. So it's wanting to know the secant of 60. Well, if I don't even draw it on the unit circle, this is 1, 2, square root of 3. And I want secant. Secant's the inverse of cosine. Cosine is 1/2, so secant would be 2. Let's make sure now if I do, I'm going to just check it. 7/3, 180 over 3 is 60, times 7 is 420. 360 minus 420, or 420 minus 360, 60 degrees again. And secant, or cosecant of 60, cosecant's the inverse of sine square root of 3 over 2, so it's 2 over the square root of 3. When I rationalize that, 2 square roots of 3 over 3, which matches this answer. I'm just checking. Does that make sense? All right. Terminal point, that just means they're both positive, so I've got this terminal point that's 3/4 square root of 7 over 4, something like that. This is cosine. This is sine. So I want to find sine. Well, sine is square root of 7 over 4, so that's the only one that's that choice. That's it. Right? You remember x and y are cosine and sine? Okay. All right, how do we determine whether something's even or odd or neither? I think I did a problem like this on the video, the review that you guys watched.
I didn't notice this one on the video.
Well, it wasn't this problem, but it was one like it. Nope. You remember from Algebra 2? Okay, so graphically, a function is even if it's symmetric around the y-axis. This is an even function. Okay? A function is odd graphically, and I'm going to show you algebraically too, if it's symmetric around the origin. And a function is neither if it's neither symmetric around the y-axis or the origin. Okay, the way you test this algebraically is you plug negative x in everywhere there's an x. Okay, so if f of x equals 9x squared cosine x, I'm going to plug negative x in for x. If I get exactly the same function that I started with, it's even. If I get exactly opposite the function I started with, meaning the opposite sign, it's odd. If it's neither, then it's neither. Okay? So when I plug negative x in, negative x squared is just x squared. So what is cosine of negative x? This was one of those identities, properties that we talked about. But if you can't remember, just do a what if. Okay, cosine of 30. Well, cosine of 30, okay, is square root of 3 over 2. What's cosine of negative 30? Well, that puts it in this quadrant, but do you notice that x in the first and the fourth quadrant are both positive? So cosine of negative 30 will also be square root of 3 over 2. Okay, so this will stay when I put negative x, so it's even. Because you get exactly the same thing you started with when you put a negative x in. Does that make sense? Mm-hmm. If it had been, I'm trying to think here. Something like this, and then I plugged in negative, I would get exactly the same thing here, but when I do sine x of negative, it becomes negative sine x. So it is not exactly the same, and it is not exactly opposite, because if it were exactly opposite, that would have to be negative, right? And it's not, so it's neither. Follow algebraically how to do that?
Yeah.
Okay. Once we get into the next chapter where we're actually graphing sine and cosine functions, you'll be able to see graphically a little better, but for this problem you have to have done it algebraically. Come on. Oh, was that it?
Yeah, that was it.
Wow. Okay. All right. So I haven't graded the quizzes, but I'll get those graded. And the rest of the period, you guys can, if I can find them. Work on the reviews, so I'll find them for you.
I'm going to focus on small mistakes and overthinking.